Hey Algebra 2! Today I'm here to talk to you about Chapter 2.4, Writing Equations of Lines. There are two different forms that we can write an equation of a line in. The one we've talked about so far has been slope-intercept form, so you should be pretty familiar with slope-intercept form, y equals mx plus b, where m stands for the slope and b stands for the y-intercept. And if you are given the slope and the y-intercept, this one is the fastest to write. So for instance, if a problem tells you m equals 3 and b equals 7, then you just really quickly write y equals 3x plus 7, and you're done. So if you are given that information, that's the quickest method to writing an equation. Otherwise, we're going to be looking at point-slope form, and point-slope form is if you're given a slope and a point. So here's my slope, m always stands for slope, and then my point is x1, y1. And so your point then, there's your x-coordinate and there's your y-coordinate. So the x and the y without subscripts are the x and the y in the equation. So those are our two forms. Now the third thing I have listed here is if you're given 2 points. So if you're given 2 points, you're first going to find the slope, because notice either way, whether you do slope-intercept form or point-slope form, they both have a slope. So you have to have the slope. And then you can use point-slope form because you'd have the slope and you'd have a point. So there's your point-slope form. Now I'm going to tell you now, I'm going to try to remember in class, is that all answers, so on your homework assignment today, all answers must be in slope-intercept form. So even if it's under a section titled point-slope form, I want you to rearrange your point-slope form to put it into slope-intercept form, and I'll give you a couple examples today on how to do that. So the first one here is that we have a point of -3, 4 and a slope of 2/3, and we want to write the equation. So given a point and a slope, the fastest way is going to write the equation in point-slope form, which, if you remember from the previous slide, is y minus y1 equals m times x minus x1. And you're going to fill in y1, m, and x1. So this is going to be y minus, the y from the point is 4, equals the m that you're given is 2/3, times x minus, the x from the point is -3. So we filled in those 3 things. Simplifying it a little bit, that is going to be a positive. Okay. Now, that is an equation in point-slope form, but I just said that I wanted all of your answers to be in slope-intercept form. So it takes us 2 steps to get it into slope-intercept form. Your first step is going to be to distribute the 2/3. So it gives us 2/3 x plus 2. And then your second step is going to be to move your y sub 1 over. And then you have an equation that is in slope-intercept form. So that's what I want. Now, a second option, if you want, start in slope-intercept form. And then what you're missing is the b. So plug your point in as x and y. So there's my y equals my m, my x, plus b. Solve this for b, and then rewrite it into slope-intercept form, and it's going to look exactly like that. So you have 2 options, and you just pick the option that you're going to do better at. I tend to go slope-intercept, or sorry, point-slope, but you can definitely go slope-intercept. So this one's going to tie in a little bit of that parallel and perpendicular we learned about in the last section. Write an equation that passes through this point, so I have a point, and is parallel to this line over here. Well, if you remember from last time, parallel means same slope. So this is telling you in several words that you're going to write the equation of the line that has the same slope as this line. Okay, because parallel means same slope. Write an equation line that has the same slope as this line. Well, this line has a slope of 2. All right, so if I have a slope of 2 and I have a point, and again you can do either point slope or slope intercept. So if I do point slope, I'm going to plug in those 3 values, 1, 2, 3. Those values get replaced. So this is going to look like y minus a negative 3 equals 2 times x minus 2. And then I'm going to rearrange this to be in slope-intercept form. So it's going to be y plus 3 equals 2x minus 4. And subtract 3, y equals 2x minus 7. If you're much more of a slope-intercept person to start with, why don't you try it out and make sure you get the same answer. Our next example involves what happens if you have 2 points. So you have to start with your slope formula. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, whichever way you're going to do it, you have to have the slope. I'm going to pick 5 first for my y's, so I'm going to have 5 minus 2, which means I'm going to do 1 minus 4, because you got to stick with that same ordered pair you started with. So it's going to be 3 over negative 3, which is negative 1. That's my slope. And then if you want to use point slope, pick one point, does not matter the point, and you're going to plug it in. So I'm going to have y minus 5, that's the y from the point I chose, equals negative 1, that's the slope I just found, x minus 1, which is y minus 5, equals negative x plus 1, y equals negative x plus 6. And just to show you real quick, if you had picked the other point, y minus 2 equals negative 1 times x minus 4, y minus 2 equals negative x plus 4, adding 2 to both sides, you would have gotten the exact same equation. So it doesn't matter which point you pick, you get the same result either way. Last thing we're going to talk about today is direct variation. And we're talking about this now because it really goes with slope-intercept form. So here's my slope-intercept form. But if b has to be 0, so we're going to say like if that has to be 0, you get y equals mx, that we're just going to relate here to y equals kx. So k is really your slope, but in some instances it's maybe more accurate to talk about it as a constant of variation. So this can be as easy as maybe representing your pay. So maybe you get paid $8 an hour. So that would be your constant of variation would be that 8, and then x would represent your number of hours, so that y then was how much you got paid. Direct variations are as one quantity increases the other one. So the more hours you work, the more money you make. The faster you go, the greater distance you travel, which then if we look at d equals rt, if that's your k value, right, or the longer you travel, the further you go. Okay. So that's direct variation. If you graph it, they're going to be straight lines that always go through the origin, and that goes then back to that b being 0, that they'll always go through the origin. So typically the problem will tell you if your variables have a direct variation, and so this does, it says the variables x and y vary directly, okay, and x is 15 when y is 3. So first of all, we want to write and graph an equation relating x and y. So if my general equation is y equals kx, and it says that y is 15 when x is 3, can I solve this for k, my constant of variation? So if I divide by 3, k equals 5. So my equation relating x and y is going to be y equals 5x. Make sure, if you have an equation relating x and y, that it has an x and a y in the equation. This is not an equation relating x and y. There is no x or y in it. This is an equation relating x and y. If x is 1, y is 5. If x is 2, y is 10. That relates x and y. This does not. I'll remind you again later, but that seems to always be a hard part. So if we want to graph it, though, I'm just going to treat it like slope-intercept form. I'm going to do an easy graph here and count by 1s on the x and count by 5s on the y. So it starts at the origin, and my slope is up 5 over 1, up 5 over 1. There we go. So the second part is find y when x is 9. So if I have this equation, if x is 9, then I have 5 times 9. Well, y then is 45. All right, that's what I have for you today. Let me know if you have any questions. Have a great day, and I will see you in class.